everyone, welcome to my channel Data Structures Hack. In today's video, we are learning a very important data structure, and that is graphs. Let us see what graph is. Let us also understand how it's pictorially represented and how many types of graphs are there and what are the differences between each graph, and also the space and time complexity of the same. So let's dive into what a graph is. A graph is a collection of nodes that may or may not be connected. So what do we mean by nodes? What do we mean by connection? Let's look into it. So in today's video as well, I'm gonna use a couple of pieces from the game Catan, and let's see how it is pictorially represented. So these coins from the game, I'm gonna use them as nodes, which are elements that are in the graph. They are also referred to as vertices, and I'm gonna use these red roads of Catan game as connections, and these are referred to as edges in the graph. Okay, so let us start. So I'm placing the node 12 for the graph, and this is the first node I'm placing. So I'm gonna have a connection because I want to add in another node into the graph, so that is 3. So over here we can see that this connection or an edge is basically a bridge between 12 and 3. So there is a connection between 12 and 3 through this edge. Okay, so both 12 and 3 are vertices, and I'm just like having a connection to them, and I'm connecting another edge from 12 to 2, and I'm just gonna add a few more so that this graph becomes a little bigger. So I added a vertex 11, and next from 2 I'm gonna add another vertex 4, and let's add a vertex 5 from 3, and let us add a vertex 10 from which connects from both 5 and 3. Okay, so this is a graph. So what do we understand by this? This more looks like a mapping, right? So it is exactly that. Like, graph is something to do with, like, if I want to like go from the point 12 to point 4, how do I go? What is the path I'm going to take is exactly what graph is going to define us. Okay, so this graph, we do not have any particular direction, right? So it's more like we do not know whether the edge is connected from 12 to 3 or 3 to 12, so, or 12 to 2 or 2 to 12. So we do not know which direction it's pointing in. So that gives us the first type of graph that is named as undirected graph. For example, if I start adding an arrow mark over here where there is a pointing, right, then it will become a directed graph. So basically then if I'm like adding an arrow over here which says it's gonna be like this, the edge is like pointing from one to another, then that means we can reach 3 from 12, but we cannot reach 12 from 3 because the direction of the arrow is showing which way it is traveling in. Okay, so that is a directed graph. So we already know 2 types of graphs from this particular diagram, and that is directed and undirected graph. So what other types of graphs are there? So for this particular example, we are assuming that these are in both the directions. It's both in towards 5 and from 5 to 3. So all these other red blocks, right? So I'm just gonna add the direction to you. So we are having an undirected graph basically, so it's connecting on both the ways. Okay, so why am I showing this? So this is like this, right? So like it goes and it comes back. Okay, so we can see that in this graph there is a cyclic graph as well. I'm going to add one more here because I think it's not visible in the video. Okay, so this has a cyclic graph as well. So if we observe in the part of the graph, there is a place in the graph or in a path in the graph which will lead into an infinite cycle. And that is, if we do from 3 to 5, 5 to 10, 10 to 3, there is a cyclic graph that keeps going on. So that's why there are two types of graphs again, which will come into picture. And that is a graph that contains cycle, that is a cyclic graph, and a graph that does not contain a cycle in the path, that is called as an acyclic graph. So till now we have learned 4 different graph types, okay? And what other graphs are there? So there can be like one more graph. Like I'm just gonna add this 9 and I'm gonna remove this and I'm gonna make it like this, okay? So there are connected and disconnected graphs, okay? So if all, like the previous example, like till when only this was there, right? Like before I added this new vertex 9, this particular graph is a connected graph. But we can also have disconnected graphs like this, which is a graph, but there are few nodes or vertices which cannot be traversed from every node in the graph. So for example, we cannot traverse to either 4 or 9 from any of this part of the graph, right? So that is where a disconnected graph comes into a picture. So let us try to see what are the examples for each type of graph that we covered. So when it comes to directed and undirected graphs, right? So if we have people on Instagram and we are following someone, that leads us to a directed graph because we need to have that. So if you follow someone, that doesn't mean that the other person is also following you. So that is a directed graph. So you have only one way of approach. And it becomes an undirected graph when both of you are following each other. But that is more prominent in a Facebook page, where if you send a friend request to someone, it's not that the other person also needs to send another friend request to you for it to become a two-way graph. Like if one of you send and the other person accepts it, it's an undirected graph because both of you are friends of each other and both of you can see everything of each other. When it comes to cyclic graph or acyclic graph, what would be a cyclic graph? I think the best way to put into a cyclic graph would be a wiki page, where you would be trying to search for something on wiki, and there are multiple links on wiki which will take you into other pages, and they in turn can lead you back to the first page or some other page which you had previously referred to. So that becomes a cyclic graph, okay? And what other graph do we have? We have connected and disconnected graphs. For connected and disconnected graphs, I think we can get on to the example of islands. And when you have a transport system based out of road or like based out of land, and you cannot get a connection onto the island through water, because that is not a land which is being connected, right? So if suppose all this is a one country and this is an island, like you do not have a direct road connection, but you have a ocean connection. That is a different type of connection. So it is a disconnected graph that can be taken into as an example, okay? So let's jump into the time complexity and space complexity of graphs. So as we can see, we need to store both vertex and the edges of each element. So that would lead us into O of V, and plus, because we are also saving the edges, it will become O of V plus E, space complexity, okay? How does time complexity work? There are two methodologies to traverse through graphs. One is depth first search and the other one is breadth first search. which we will talk about in detail at a later point of time. And but the time complexity still remains as O of v plus e. So the time is also, because we need to store both of, I mean, basically we traverse through each vertex and each edge. So that's why it becomes v plus e again, O of v plus e, time and space complexity. That's all I had for today's video. I hope you guys really did understand, and thank you so much for watching. Have a good one.